today for this baseball biomechanics and industry talk, we've got William Buddy Clark from Diamond Kinetics, Patrick Cherveny, currently with the Cleveland Indians, formerly with Blast Motion and Callaway, Scott Coleman from KinaTrax, and Patrick Moody from DARI Motion. And I want to keep the intros kind of brief and open it up to each one of them to basically start with, how did they get here? How did they get to this position that they're in, working in the industry? I'd like to open up with Buddy, if you'd like to start. Kind of like, how did you get into, I guess, Diamond Kinetics, where you are now, and baseball biomechanics and industry? Sure.
Thanks. So for me, it was probably a non-typical route, although I think everybody says that. I wear two hats. So I'm actually, my day job is a faculty member. I'm a professor in mechanical engineering at the University of Pittsburgh. And so my research is in mechatronics and with some biomechanics applications. And my route to industry and Diamond Kinetics was, I founded the company. So that's not your typical hiring approach, but I started it because of years of coaching youth ball and ball teams my kids played on. And I saw the need for more objective measurement in the sport. And so, I actually started developing the sensors myself. And so that was my route into it. And the company came out of that. So I've hired a lot of people since then. So, but my own route was probably not typical.
Yeah, I got you. That's great. Let's see, let's go with Patrick Moody on this one next. How you got where you are now with the...
Hey guys. Can you guys all hear me? Making sure we got a thumbs up there. All right, perfect. Yeah, my name is Patrick Moody. I got into biomechanics and into this a little uniquely. Was thinking about medicine, but ended up loving the idea of what was behind the science of implants and just biomechanics. Background was in kinesiology and master's in biomechanics. But as I was leaving, my master's work was using motion capture equipment, and back around the turn of the century, I was kind of wondering who's screening athletes. And the more I looked out there, there weren't that many people in industry that were doing it. And my entire objective was, if we track people before they're hurt, get really good baselines, and then just monitor that, store that, if they got hurt, we'd have a really great return to play criteria. So that was kind of the dawn or the reaching out, and I just wanted to do that with my life. I didn't really know how big of a chunk I was biting off probably at the time, but that started it, and then slowly but surely we started engaging more and more, and the birth of DARI kind of happened a little while later as we got more feedback from coaches and teams and people. So the sports idea, being sports specific now, we were kind of maybe based on fundamentals or functional screenings to start. And we really evolved into orthopedics, but I would say my true passion here is kind of always been in the advanced biomechanics, specifically things like pitching, throwing, and swinging. So it was just a goal, frankly, of life, and there weren't that many people out there doing it, and I just would rather be spending my days doing that than something else.
Yeah, that's great. Thank you. We'll go over to the other Patrick Cherveny.
So I started in orthopedic biomechanics and mechanical test lab, transitioned to Callaway Golf in early 2000s to start looking at some of like swing profiling capabilities. And since that point, I've been heavily involved with like the kind of the latest and greatest biomechanical system technologies, having worked directly for companies, worked for Callaway Golf, worked for Blast for 3 years, as well as being a consultant to other technology companies, primarily on the IMU side, developing algorithms, working with athletes like with the United States Olympic Committee, and then transitioned to the Indians about 1.5 years ago. And so just to kind of sum it up, like I look at myself as kind of like a technology aggregator and do a lot of algorithm development around the different types of technologies.
Gotcha. Thank you. And then Scott Coleman with KinaTrax.
Thanks, Anthony. So I went straight from an undergrad kines program into biomechanics masters at the University of Delaware. From there, I fell into a installation and training position for Motion Analysis Corporation. So basically traveled really around the world, which was a great experience, installing and training people how to use those systems. Then went to work in a pediatric gait lab, AI DuPont Hospital for Children. They were a customer of Motion Analysis, so they hired me. From there, I went to Baylor Medical Center. I worked in orthopedics and primarily did orthopedic research with total joints. Worked with U.S. track and field and some of the top U.S. golfers in the country, located in Dallas. And then worked for a second motion, marker-based motion capture company for several years. And then just recently moved over to the markerless world with KinaTrax back. First week was winter meetings, so crash course.
Nice. Yeah. I think I like that the underlying theme from a lot of answers are, trying to get objective data in order to help athletes, work with them, and especially putting a lot of priority and emphasis on like an assessment and retest piece, like knowing where they are and then being able to check back in. I think there's so much value in that. As far as with you all having worked in industry or still currently working in the industry, as far as like experiences and opportunities go, is there anything specific that was created for you or you think would be important for anyone looking to get involved in baseball biomechanics and industry, like a certain trade, skill set, experience that they should go into or where they should look? Just open to anyone who kind of wants to jump on that.
Yeah, I'll start. I would just say find the right program and mentor. If that's their focus, I would think that's the obvious way to go, the quickest way there. Pretty much every job I've had is due to my mentor, Dr. Jim Richards. Every single one of them to date has been, because of the contacts he's had. So that would be my recommendation.
I would say to, try to set yourself apart. Ben made a comment yesterday about he always advises people to learn how to program. And I think that's actually something I say a lot to students. And then do something that makes you different from the rest of the people that are playing. Have some varied skills in your resume, and build some things, build up a portfolio. These are all things I think that set you apart from lots of other people.
I think that's this is Patrick. I think that's a really good point. I'll piggyback that from Mr. Clark. The fact that coding is really important. So things like Python libraries and R, getting into not just MATLAB and maybe even LabVIEW, maybe historically, but being able to pick up those languages and think about the machine learning world, I think is, if you're in the ability of education now, you really should be branching into that, because those are assets we know we need in the field. And they're complicated, but the more you can diversify your portfolio, not only in just projects, which I think is a good way of demonstrating it, but the languages and can operate in can be very, very appealing to anybody in the industry.
Generally add that, like I've been more in applied sports biomechanics roles as opposed to like academic. And I personally prefer that type of avenue because applied, I think, is much faster pace, where you have to really get after the signal, especially if you're trying to develop a solution that you're going to commercialize. So I think related to that, like there's been a lot of talk on the programming side, and that stuff's all very important on how to analyze problems. To me, one of the biggest differentiators is critical thinking skills. Like we can collect a lot of data, but you have to know what you're after, have some sort of framework to work around to actually analyze and create a solution that's actually going to be actionable. So I think the critical thinking skills is a big part of that. And so being abreast of latest research, but like you've got to surround yourself with all types of research. You've got to get like differing opinions. It can't just be a pigeonhole. And I think a lot of times, some biomechanists get kind of pigeonholed into like what I call black box science, where they're pushing buttons on the data capture and analyzing the problem that way. You have to have some critical thinking skills as to what's actually important.
Yeah, that's a great point.
I got
Go ahead.
one more in that. I think it's really important with Patrick's point. Sorry, it skipped my mind, but think about the delivery of the visualization, right? So when you're talking about critical thinking, sometimes you see a lot of data, but if data is just sitting and it's not used, finding ways to communicate, I think are really, really important here as well. So I think that falls a little bit on what Pat was saying.
Yeah, and along the lines of the communication and the connection, and a lot of you touching on constantly getting more information, getting like a greater breadth in terms of what I think there's so much value in that. And actually, when Ben made that comment yesterday about programming, my initial thought when he was talking about programming was more along the lines of like strength and conditioning programming, athlete like training programming. But I think there's value in expanding your, I guess, repertoire to be able to communicate with everyone. Because as we've broken up these kind of panels over the last couple of days with academia, MLB, industry, all of those people need to be able to talk some sort of language together, right? Whether it's being able to talk to the programmers, also working with a coach, understanding their needs. And I think, industry can be a very valuable like bridge between a lot of those, whether it's with the product specifically, or, how they kind of, I guess, feel out requests from those other two areas. Are there any, and that's another question I wanted to ask, if there were any, gaps that you thought that you in industry can specifically fill in regards to academia needing something, professional baseball needing something, whether it's like product or service along those lines, and how you strengthen that like communication and connection. Besides, I guess, knowing what they want.
That is a tough question, and I might ask that you funnel it just a little bit, a more direct question. I think I'm swirling with possibilities.
Right, yeah. So with like, I think professional baseball, being able to understand and connect with them, but not be so removed. I think like sometimes industry or companies getting involved in baseball biomechanics, they get stuck in their world of like making their product, but maybe it doesn't work for the situation. Maybe they're not involved with the coaches. So whether that's hiring on baseball related staff or someone with playing experience, whether it's like having that in the dugout experience or whatever it is to make it valuable.
Yeah, Anthony, I think I can touch on that a little bit. So I think part of that is like from the system technology standpoint, from the company perspective, like they have to focus on like a repeatable and reproducible measurement system. It has to be accurate. Then there's other characteristics that go with that, like is it a natural environment for the athlete? Is it scalable across an organization? And so to that point, I think that's where concepts like voice of the customer, consumer come in, where you have to actually work with the teams or whatever entity you're working with and get that feedback. Because again, sometimes tech can be very lab-based, but once you start introducing that into like a professional organization, it can be more one-off as opposed to scalable. So I think that interaction with the teams is important from like a workflow perspective. Like this is how our data is organized, all those types of viewpoints. And then as importantly is like what type of information are we providing? And I think that's where like there's kind of that fine line with a tech company. You're providing accurate data, and then is the team and the analysts going to go work with that, or do they need like actual insights from the data from the company itself? And a lot of times that will be spearheaded on based on discussions with, it can be with the team. It can be like, there's times from like my role with being with the team of working with a university or something where you're actually trying to get technology that you can leverage and bring internally.
Yeah, that's actually like right at what I was kind of getting at, is walking that line of, whether it's having a product or a service that works for the athlete and the coach, but also has like the robust back end that's accurate, valid, and kind of making it so that if you try to ask a player or coach to just like operate a biomechanics lab with no experience, it's not going to, work. But we need to like walking that line, how you kind of navigate I guess like those two sides.
So I could speak to that a little bit, partly from the university side. You know, when we teach our engineering students, it's so easy to fall in love with your technology, and a lot of times engineers look at the technology as the end of the whole process, because if it's wonderful measurement tool, everybody must love it, right? And they often forget about the user, and so you know, we have to carry that over on the industry side as well. And it's a real challenge to keep the user centered in the process and not just get totally wrapped up, like some of the others have said, in the technology. And so I think it's something that engineers and up and coming students and people entering in the field can sort of train themselves to not just have blinders on with respect to your tech, and think about the end application and talk to the users and the coaches and the people that have to actually deploy this stuff.
Yeah, it's a great point.
I think that's a really good point from both people so far on the panel here. And being on the engineer side and develop a deliverable, you might fall in love, like you said, with it so much that you keep going down the rabbit hole. And oftentimes, what's digestible is very easy, and you might think, why is that the only piece they're looking at? And it's really related to the workflow and what is possible right now. So it might be one of the more overlooked things is what is just digestible and usable now that meets the workflow that a biomechanist coming into the field needs to remember, right? That everybody's iterating with here, that there's just levels of digestion, right? Give them a little, and they'll come back wanting more. But if you hit them with the fire hose, it usually doesn't go very well.
Yeah, and I always come from the standpoint where I've been the end user. So when I have accounts, different teams, whether it's MLB teams or at the college level, they all have different needs. So you just have to really identify that and kind of work backwards. I think that's the most important, is to pretend you're that end user and help them reach their goals.
And Anthony, just add one other comment to that is kind of what Buddy and Patrick were touching on is technology companies are trying to deliver a solution, but what I don't think a lot of people understand is, especially these emergent technologies, they're usually very small entities with limited resources, both like personnel and budgetary. So I think it's really important to interface with your users up front, because otherwise you can go 3 months down the road and develop something and they come back and say, we can't use this. And that can be a death cycle for a small company.
Yep. Yeah, I like that a lot. We got a couple questions that have came in from the Q&A. A few of them are related to coding languages, where to start, gaining proficiency, developing programming skills. There any, specific, if you have like a suggestion to jump in, or I guess like where each of you started, if you have programming backgrounds, coding skills, kind of like a good a place to start for that?
I would say that in general, most people that come from like a biomedical engineering background typically have MATLAB experience. But as you get into industry, you typically want to have something that is a little more universal in programming. So I think Python's a strong programming language for a lot. Some people talked about R yesterday. That's a little more on typically like statistical analysis and looking at data sets. So it's important, but especially if you're like on algorithm development side, MATLAB and or Python are typically used.
Yeah, from my side, my background's in LabVIEW, which is almost a dead language nowadays in our world. But Visual 3D is, it's not a language, but it's the program that we use the most. And I think Anthony, you guys use that, pretty heavily. So.
I would say
got a few. I would say, you can go ahead. Sorry, Alan.
Oh, thanks, Patrick. So it does depend a little bit on the end use, whether it's going into a product that's an embedded product that, maybe C or something related might be better versus if it's analysis, Python might be the right tool, or R. So think about where you want to end up. But I think a general rule, just learning fundamental programming, and there are lots of places you can learn that, even in free and web-based tools if you can't take a university course, Code Academy, and all kinds of things that are on the web that are great resources. Just learn good fundamental programming, and you can apply that to just about any language.
Yeah, I would hit that home too. I think again, R feels a little more academic. I do think Python is something much more industry used. I think you go database architecture wise, you could get familiar with like SQL databasing is a little different. I use PHP for some of our mathematical evaluations, but getting comfortable with HTML and Java, I think is a good idea for a biomechanical engineer because it's that visualization. And then something kind of on the side, but I would say is really emerging is dashboarding. So Tableau, Power BI, getting into some of those and getting familiar with the architecture, like you said. So there's tons of stuff I would echo about the online education you can do for free. Those Code Academy is a great one, and they have all of them. So you can pick up a lot of different skills, get some certifications even, but the more in there, at least from our side, I kind of expect you to have some capabilities in the biomechanicals and knowing modeling and some of the equipment and even the physiological. Those are kind of base blocks that you do have to have. But if you want to diversify yourself, those are really excellent categories, I think.
Hey, Anthony, I just wanted to touch on one thing that Buddy said, which is very true, like within a company like that is, again, my role was more focused on algorithm development. And so that was more like exploratory, and then Python worked for that. But like when we actually pushed it to like the product, we had a full stack development team that would do the software development. And so that's where you like, you're developing your code in one language, but then you're working with the actual software development team to get it introduced and rolled out, because the firmware, all the other things that go with that are basically how the system actually works.
Yeah, I think as a self-taught coder over the last few years, I really like, Buddy's point about the fundamentals of coding and programming, because regardless, where you start language-wise, once you start to understand the fundamentals, I think you can branch off into other ones and pick other ones up a lot easier as you kind of go. And the syntax just changes here and there. But speaking of the development teams, one of the questions in the Q&A was just about the size and roles of product development teams within baseball, I guess at each of your respective companies. Scott, do you want to start with that one?
Yeah, so we're definitely a small company. We have 10 employees, and we have two main programmers.
Patrick, Moody?
Probably in the range of each product, 2 to 5 would probably be accurate. Someone, like they've all mentioned, you might have a back-end architect. You might have someone that's the mathematical and working formulas. Someone's a little bit more visual, but they're all biomechanical and relationships. They just take on different roles. And then there's usually someone that's somewhat application or partner based that's drawing feedback from those populations and people and gaining feedback to bring back to the team.
Buddy?
Yeah, so I remember the days when it was just me trying to get it all done to get it going. And fortunately, it's not relying on me anymore for sure. But we've now grown. We're still a scrappy startup, but we've got several developers and several engineers, so we get to kind of cover both sides of the problem. Yeah, so it takes a team though. It's a lot of facets.
Yeah. And then Patrick, with your time at Blast or Callaway?
Yeah. So like at Blast, it was not just baseball. There was a golf solution as well. But, a lot of different working teams. So like on the algorithm development, there was like 2 to 3. Once you transition to kind of the full software development, there was a team of about 5 to 6. We also had a cloud team of about 3. Q&A team. So and then we also had like the sales that went with it. So as Blast had grown over the years, it started scaling a little bit to meet the demand. So it's still a small company, but it's a little bit larger. So it's close to like 30 or so related to baseball.
Gotcha. There's a try to get a couple of these last questions in, but one of them, well, this is specifically for Scott, I guess, is the most liked question right now. What are the player rights to markerless data? Away teams likely don't give consent for data capture. They probably don't even know if data is being collected. Facial recognition 2.0. I think this is actually a good question for everyone in industry about data access, as far as like, using the technology, who has it. So Scott.
Yeah, sure. So that's a interesting question. That's been addressed, I guess, several times over the years. So right now, the teams own the data. So there's no facial recognition. I mean, it's video data. We have a partnership with MLB, so they're fully aware of the systems and what and how we do. But yeah, the teams, individual teams, own that data.
I'd add that in the past, that's been the case, is that if you have your own kind of contract with the tech company, it's the team that owns it. But this year, Major League Baseball has rolled out Hawkeye to replace the previous StatCast system, TrackMan specifically. So the Hawkeye data is actually owned by Major League Baseball. And so teams have access to that through MLB.
Yeah, and then just gonna try to end it with this last question. I think it's a good one. What are the biggest barriers / areas of frustration, future development in your respective companies? Patrick, Moody, you wanna start on this one?
Yeah, I'll hit it kind of quick, maybe quick. With markerless motion capture, and it's emerging right now, a lot of the comparisons are against historical standards or other companies and technologies out there. And as a biomechanical community, I always wanted to say there's a lot of questions maybe out there, and it's not really about tracking human movement. We're all systems, at least that we're working with, do a great job of tracking it. What we see as a problem and maybe frustration are the models that are used. So what talk that was given yesterday about the shoulder and elbow and trajectories during cricket, the same things apply here. If you're picking a different model and trajectorizing ever so slightly different, it can be different in its comparison. So agreeing on models as a community, as the ABBS, I think could be a great piece to help remove some frustrations from our side and help create continuity.
That's good. That's a great point. William, buddy?
Sure. So I'm actually going to go back to maybe one of your first questions and say that it's, I think the thing that always challenges us the most is figuring out how to get the data to the player or the coach in the easiest way, the way they most quickly understand it, and kind of get out of their way with the tech, right? Ideally, they just go out and do what they normally do, get the answers they need, and just sort of have it be seamless. And that's something that's always front of mind, and maybe the most difficult thing to do overall.
Yeah. Scott?
I would say the biggest frustration is just proving to individuals and teams that the data quality is there. The amount of data we can collect and the seamlessness that Buddy just mentioned. I mean, fortunately for what we do in our avenue of delivery, that is there. I'm kind of shocked that more people don't take more, as much advantage of it as they could right now. And I came over from the marker-based world just because I was convinced myself that this was the right time. So yeah, it's just getting people to buy in to, hey, this data is as good as marker, and if not, the situation and the amount of data in game, I believe it's there. So it's just adding people, adding teams, universities, college teams. So that's the biggest hurdle and obstacle and frustration, I guess, if you call it a frustration.
I'd speak more. Oops, go ahead.
Go ahead, Patrick. One last comment.
Okay, I would just quickly say that, like, from my standpoint, it's more about the aggregation of technology. When you have a bunch of different providers, there can be difficulty in collecting all that. So moving forward, ideally, you start getting some aggregation from that. I think Hawkeye is going down that road. But the last thing I'll say is, like, from the tech standpoint, like, tech changes really fast, different types of technologies, and who was a leader 2 years ago may be completely different in 2 years.
No, that's really fair, and I think you guys all bring up good points, you know, that we're discussing. And I think, you know, Patrick, Moody, you brought up, you know, kind of like that standardization, and maybe that's where ABBS goes in these discussions about how we bring things together. And maybe that, you know, Scott, to your point, kind of isolates and starts to create general buy-in if we can all start to agree on different approaches and different things. So unfortunately, we do have to move on, you know, in our programming, but really appreciate you all for joining us today, and thank you so much.